Okay, what if I told you that the deepest secrets of your own mind, your thoughts, your memories, all that creativity, could be explained not by biology, but by pure mathematics? It's a pretty mind bending idea, right? Well, today we're going to dive into how the abstract world of geometry might just hold the key to understanding our own brains. Think about it for a second. The human brain is this incredible paradox. On one hand, it can store a memory of your childhood home with perfect, stable clarity for decades. But then, in the very next moment, it can spark a completely new idea, something that's never existed before. So how can one organ be both a super reliable library and a chaotic engine of pure creation?
And here is where it gets really interesting. The key to cracking this might not be found by looking even closer at neurons and synapses. No, a new model is suggesting that the answer lies in the work of a brilliant mathematician and in the hidden geometry that governs these incredibly complex systems. So to get our heads around this, let's start with a really powerful analogy. I want you to imagine all the possible activity in your brain as this vast, complex landscape. Every single thought, every memory is like a path or a pattern that forms within this landscape. And if we're going to understand it, well, we're going to need a map.
And of course, every great map needs a map maker. For our purposes, that map maker is the brilliant mathematician Maryam Mirzakhani, who was the first woman ever to win the Fields Medal. You can think of her as this pioneering explorer of these strange, abstract geometric worlds that, as we're about to see, look shockingly similar to the landscape inside our own minds. So what exactly was she mapping? Well, it's a concept called moduli spaces. Now, I know that sounds super complex, but think of it this way. Imagine a single shape, like a donut. A moduli space is like a universe that contains every single possible version of that donut you could ever create by stretching it or bending it or twisting it, as long as you don't tear it. So it's not just one shape, it's a map of all of its possibilities.
Okay, so we have our map maker and her incredible map of possibilities. And using this framework, we can actually look at the brain's landscape at three totally distinct levels of complexity. We're going to build from a single little spark all the way up to a storm of creativity. Let's start with the simplest level.
At the very simplest level, you've got the predictable firing of a single neuron. It's just a clear signal. On our geometric map, this is like something called a geodesic. And that's really just a fancy mathematical term for the most direct, efficient path between 2 points, like drawing a straight line right across the landscape. Simple cause, simple effect, predictable. But then things start to get way more interesting at the next level up. Here, you have local groups of neurons firing together in these structured patterns or motifs. So on our map, this isn't just one straight path anymore. Now it's a whole network of intersecting trails. And what's amazing is that Mirzakhani's work gave us a way to measure this growing complexity. It's not random or infinite, it actually expands in a structured, predictable way. You can think of it like a city grid expanding, not just a chaotic explosion. And what about the highest level? Well, that's pure creativity. Here we're seeing vast networks, millions of neurons firing in these complex, unpredictable waves. This lines up with what mathematicians call an ergodic flow. It's this dynamic, chaotic system that eventually explores every single nook and cranny of the entire landscape, kind of like water flowing until it's filled every possible space it can. On the surface, it just looks like pure chaos. This table right here just pulls it all together perfectly. You can see how at each level of brain activity, from that single neuron spike all the way up to a chaotic network, there's a direct mathematical counterpart in Mirzakhani's work. But I want you to look at that last row. It suggests there's something beyond pure chaos, a hidden structure. And this is the most crucial piece of the entire puzzle. So that leads us right to the most important question. Is that chaotic storm of brain activity we talked about, is it truly random? Or is there some kind of hidden order, maybe a secret set of rules that's governing all that chaos? Well, this is where the big breakthrough really happens. The answer is this amazing concept we can call structured chaos. It's a state that looks and feels chaotic, and it allows for all that infinite flexibility, but it's not random, not at all. Instead, it's powerfully constrained by these unyielding, rigid geometric laws. And that is the secret to having both creativity and stability in one system. And there it is. This is the profound discovery from Mirzakhani's work with her collaborators Alex Eskin and Amir Mohammadi. They proved in what's famously called the magic wand theorem that even the most complex chaotic dynamics, they don't just fly off into infinity. They are always contained within these beautiful, rigid algebraic structures. Chaos is real, but it has boundaries. So, what do these geometric containers actually do for the brain? Well, they act like guardrails. They allow our brain activity to be incredibly complex and flexible, to explore new ideas. But they stop it from spiraling into total destructive disorder. Because a state of pure, unconstrained chaos in the brain, that's not creativity. That's something more like an epileptic seizure. Okay, so this is a really fascinating abstract theory, but let's get down to it. Why does it really matter? Let's talk about the incredible real-world implications of having this brand new kind of map for the human brain.
You see, this geometric framework, it's not just some academic curiosity. It gives us a whole new language to describe how we think. And, even more importantly, it gives us a new way to understand brain disorders. What if epilepsy is literally what happens when those geometric containers break down and chaos just spills out, totally unconstrained? Or maybe a condition like schizophrenia is related to complexity becoming too high, without enough of that underlying structure. Thinking this way could open up completely new pathways for treatments and interventions.
So we'll end on this thought. For centuries, we've heard people say that the universe is written in the language of mathematics. But what if that's also true for our own inner universe? It's just a stunning idea to think about, that the very structure of our thoughts, our creativity, our consciousness, it might be governed by the exact same elegant, hidden geometric rules that shape these far-off, abstract worlds. What do you think?